Hi guys, today I want to share with you a project I'm doing on Arduino. Um, I'm to create a siren to mimic a police car siren. Now you see how police car siren is, one light to go on, the other one come off, then the other one go off, then one come on, whilst it's playing a sound, together. You understand? Yeah. So I want to use this as an example to mimic on Arduino now. I'll be using three components, two LEDs and one buzzer. Yes, so I'll connect two LEDs to the Arduino Uno board, but I'll connect them to the PWM pins, yes, because we'll be using analog writes during our code. And we'll also connect one buzzer to any pin that we want to use on the Arduino board. Okay, so now let's get on with the code. So, so we first by first, declare initializing our variables, you understand? Yes, so we declare initialize two LEDs, that's LED 1 and LED 2. Then we also declare our buzzer. Now we initialize LED 1 as, pin 9, then LED 2 as pin 10, and our buzzer as pin 8. So we'll connect the two LEDs, that's LED 1 and LED 2, to the numbers that we stated here on the Arduino board, or I could do it vice versa. I could connect them on the Arduino board and come and, you know, stage them here, but they should be connected to the PWM pins. Now, in the void setup, this is a place where I'm supposed to run code once. Understand? So over here, we told the board that, oh, we are having three components and all of them are output devices. So LED 1 will be an output device, LED 2, and the buzzer. Yes, that's what this segment of code means. Now, in our void loop functions, we are to state the code that will run throughout throughout the program. Now, because we are making a siren, we wanted to use a loop. A loop in such a sense that it can be running, consistently, you understand? Now, to create the, you know, the blinking feature of the siren, like a police siren, we use the loop to control the LED. Now we declare initialize a variable called the brightness. Then we set that, oh, let it be equal to 0. You understand? Now we said that the brightness is less than or equals to 255 because that's the highest value analog read can contain. You understand? Then we said that let the brightness be in 10 steps. Understand? And over here we said that let's like LED 1. Let's control the brightness of LED 1 now. What we are seeing over here, like all this chunk of code is that, see, we have two LEDs, each of which wants to control their brightness, you understand? But we want to control their brightness in such a way that two of them will work sinusoidally. Sinusoidally in the sense that the two of them will work at the same time, you understand? When one comes on, the other one will go off. Yes. So what he said is that, oh, you see, we want to control the brightness of we want to control the brightness of LED 1. So let the brightness of LED 1 be 0, but it should be increasing in a step of 10. Understand? So the brightness of LED 1 will be increasing by 10, by 10, by 10. So it reaches a value which is equal to or less than 255. Understand? Now, we told the analog right that, oh, for LED 2, let the brightness be high. Understand? But reduce the brightness of it by the value of brightness we have. You understand? Now, remember the brightness is increasing by a step of 10. So if brightness is equals to 10 here, over here to be 10. So 10 minus 255, you'll be getting 255. So the LED will decrease by 10. So that means the LED 2's brightness will now be 245. Understand? So as this value is increasing, LED 1 will be increasing in brightness, meanwhile LED 2 will be decreasing in brightness due to this factor over here. By subtracting the brightness from the initial brightness or the initial value we have from here. Yes. Now, this code over here is just to create a sound. You understand? Now, what we just said is that for the buzzer, we set a frequency of 500 to the buzzer, but it should be increasing in frequency by the amount of increase in brightness we have. So what I'm trying to say is that, so as the LED is increasing by 10, the frequency of the buzzer too should be increasing by 10. You understand? Yes. And this delay is just, to set a delay of 45 milliseconds. Yes. For this, chunk of code. Now, this chunk of code over here too is similar to the one we had initially, but instead of, LED 1 to be increasing in brightness, LED 1 will now be decreasing in brightness for here. You see, let me explain further. You see, for the first part of the code, we said that LED's brightness, or like the brightness, the value of brightness should be equal to 0. Then it should be increasing steadily of an interval of 10. But over here, we are seeing that now the brightness should be equal to 255, but it should be decreasing at an interval of 10. Understand? So we declared over here that, let LED 1's brightness be equal to brightness. So we are saying that yes, the LED should be equal, like the brightness of the LED should be 10, but it should be decreasing steadily by 10. Understand? Now over here, LED 2 will be increasing in brightness. Why so? Now have a look at this. Over here, we're having 255 minus the brightness. Now remember, the brightness is reducing by a steady pace of 10. You get it? But just because it's reducing by a steady pace of 10, doesn't mean that LED2 will be decreasing. You understand? Because look at this. We have a decrease in brightness by 10, right? Okay, so 10 minus 255 will be what? 245. So if you have 245 over here, 245 minus 255 will be what? 10. So that means the value increased by 10. If this one is 20, you subtract from this, then we having 235. 235 minus 255, you're having 20. So you could see that as the value is going up, the value of this brightness, or like the value given to the PWM signal, or the value we are seeing for this analog lights, will be increasing steadily. Yes. So that will be creating an effect that as one LED is increasing in brightness, the other one will decrease. As one is decreasing, the other one will increase. So we are making a sinusoidal effect. Now over here, I explained it earlier on. So we are trying to say that as the brightness is, decreasing for this part, the tone or the frequency of the buzzer too should decrease. Yeah. They're also setting up a delay. So I'll make a demonstration of this and show it to you guys. Thank you.